Okay, everybody. Hello, everybody. Um, let's pick up where we left off before APs started. I hope you enjoyed some of those things that you were able to do, whether you did them or not. Maybe you got to enjoy them. So, neutralization reactions. Kind of give you an assignment on it before the break of the AP break, but now I'm going to actually formally teach it to you, and we'll go through it a little bit more. So, neutralization is exactly what it sounds like. It's neutralizing an acid with a base. However, in the chemical writing of this, we're going to talk about the specific products that are created. So, this is just a basic example. I got a few, and then we'll do some practice. But HCl is an acid, and AOH is a base. So, the products that you are always going to get are some salt and water. Neutralization creates salt and water. If you remember from way back in the beginning of the year, another word for something that's a salt is an ionic bond. And how do we know something's an ionic bond? It's a metal bonded to a nonmetal. So, a couple of things, right? Salt, ionic, metal, nonmetal. So, the first thing I always do is I'll be writing in HOH. That's the first. Instead of writing H2O, I'm going to write in HOH. And this is the only time I'm going to do that. The reason is when I look at the acid and the base, I know I'm always getting water. But I need to know what is the salt that I'm creating. So in order for me to do that, writing HOH shows me I've used an OH, I've used an H, and what's left over is Na and Cl, and I put it together, positive and negative. A couple more examples. I'll cover these a little bit. Should have been ready for this. Whatever. That's fine. So I think we're all kind of going with the flow right now. I'm just going to fold this over. Acid and a base equals salt and water. Acid and a base equals salt and water. So this is an acid. How do I know it's an acid? Well, it's in the reference table. How else do I know it's an acid? That's got an H. How do I know this is a base? It's got OH. Acid, base. What happens when an acid and a base come together? They get neutralized. What does that mean? I'm going to be creating a salt and water. But instead of writing H2O, I'm going to write HOH. Why am I going to write HOH? Because I could do that. Now, I want you to just quickly take note there are two H's in this formula. Okay, so there are two H's. It's only one OH. Just pump the brakes on that for right now. Let's find out what the salt has to be. The salt has to be a K, because K is +1. And the negative is going to be SO4. But what do I know about SO4? Is it plus or is it minus? I know that if it's bonded over here to two H's, okay, and each H is a +1, SO4 must be a -2 polyatomic ion. If you forgot all of that, which I taught you months ago, that's okay. It's in the reference table. Table E tells me SO4 is a -2 ion. If it's a -2 ion, I come back over here. There's a lot of review in this lesson, so we are going to make sure that you practice it. If you're not using the reference table, it's not going to work. I promise you. What has to be the charge on K? The reference table tells me that K is a +1. What does that tell me about that formula? It is not balanced. So that must mean that there are two Ks K2. SO4 is a -2 ion. So this is my formula, K2SO4 plus HOH. But we're not done yet. If there are 2 Ks over here and there's only 1 K over here, how many KOHs am I supposed to have? 2. Oh, geez. If I have 2 KOHs, how many OHs are there? 2. There's only 1. You can't change the subscript of H2O. It stays H2O. How many waters were there? 2. I got 2 H's. I got 2 OHs. Water has to be 1 H and 1 OH. Therefore, there must be a 2 HOH. I promise you, some of you are going to find this difficult because there's a lot of old stuff that is all thrown into one concept. Let's do one more. HNO3, CaOH2. This is an acid. This is a base. How is that an acid? It's got an H. How is that a base? It's got an OH. Cool, great, wonderful. H is always +1. OH is always -1. Can we not have to look at the reference table and you can tell me what the charge of NO3 is? It's -1. How do you know that? There's 1 H. It's +1. This has to be balanced because otherwise it wouldn't be given or there'd be a charge. So this whole NO3, -1 ion. CaOH. OH is a -1. There's 2 of them. 2, -1, 2, -1. Ca +2. If you're too lazy to look at the reference table, you can use the formula right there. But it's in the reference table. So this is what you got. What are you going to get? Well, I'm always going to get a salt and water. But we don't write it as H2O. Write it as HOH. And we come back here. And we cross out the H. Check. We cross out the H. Check. What's left? CaNO3. So let's put them together. Positive first. This is a +2. This is a -1. How many NO3s do I have to balance out the charges? -1, 2, 2. I'm going to have 2 of these. 2 -1s, 1 +2. Works out perfectly. Except if I've made there 2 NO3s over here and I only have 1, can't change the subscript. Big 2 out in front. But that screws up my water. Yes, it does. But now if I have 2 H's and I also have 2 OHs, same thing as before. There must be 2 HOHs. All right, so I'm going to be honest with you. This is going to be difficult for some of you. You have to be combining your knowledge of oxidation states, your formula writing, your balancing equations, your acid and base theories, and if you could put all of those things together, going to be okay. So I'm going to give you practice on this for one assignment, and then we're going to move on because we will finish acids and bases by the end of the week. All right, good luck. Try the